Hi, I'm Andy, and this is my lesson on analyzing recursive methods in Java. In this lesson, I'll show you how to analyze two different types of recursive methods. Methods that return a value, and methods that print to the console. Let's get started. As a Java programmer, you need to know not only how to write Java code, but also how to read Java code, meaning how to look at a block of code and predict what it does. That can be especially difficult to do when presented with a block of code that includes a call to a recursive method. Here's an example. Suppose you're presented with this recursive method called compute. You can tell it's a recursive method because it calls itself. Actually, this one calls itself twice. We want to determine what value this method returns when we call compute and pass the integer 31 as our actual parameter. That's a really hard question to answer by just looking at the code. So let me show you a foolproof way to arrive at the right answer. The first step is to set up a chart like this. In this first column, we'll list any calls that get made to our recursive method. The first call to compute in our case occurs right here. So we'll write compute 31 in the first column. In the next column, we'll keep track of the values of parameters and variables for this particular method call. Each method call contains its own set of these values. For example, when compute 31 executes, the value 31 is stored in the num parameter. Then this line of code executes, which stores the value 15 in the variable I. Again, future calls to the compute method will contain their own set of values for num and I. That's why we need to keep track of those values for each call to the method here in our chart. In the last column, we keep track of the method call's output, the value it returns, or the text it prints to the console. This particular method only returns a value. To figure out what compute 31 returns, we need to mentally execute the method body. This conditional statement is false because 15 is not less than 5. That means the code in this else block executes. In this case, I is 15, num divided by 3 is 10, and num divided by 4 is 7. So this method call returns 15 plus the value returned by compute 10 plus the value returned by compute 7. Now we need to figure out what values are returned by compute 10 and compute 7. Let's start with compute 10. Remember, this method call will have its own set of values for num and I. In this case, num has the value 10, which means I has the value of 5. Since I is 5, this else block executes, returning 5 plus the value returned by compute 3 plus the value returned by compute 2. Now we need to figure out the value returned by compute 3. That's pretty easy. For this method call, num is 3 and I is 1, which means this if condition is true, causing this method to simply return the value 1. For compute 2, num is 2 and I is 1, which means this method call also returns the value 1. Okay, we're almost done. We trace the return values for all the method calls except this one, compute 7. For that method call, num is 7 and I is 3, which means this line of code will execute, returning 3. Now that we know the values returned by compute 3 and compute 2, we can update our table here and figure out what compute 10 returns. And now that we know what compute 10 and compute 7 return, we can finally figure out the value returned by compute 31. So it looks like compute 31 should return the value 25. Let's see if our analysis is correct by printing that returned value. Good, so that's how you can figure out the returned value when a recursive method gets called. Now let's look at another type of recursive method, one that prints text to the console instead of returning a value. Let's predict what this call to the scramble method ends up printing to the console. Once again, we do that by first making a chart to keep track of the method calls, variables, and the output for that method call. Our first method call is this one right here. The scramble method only has one parameter and no variables. In this case, the str parameter is assigned the string ABCDE. Our base condition is not true, but this condition is true, so these 3 lines of code will execute. Those are the output for this method call. This first line of code will print the letter B, since the substring method call returns the character at index 1 in str. The second line of code will call scramble CDE, since the substring call returns the characters from index 2 to the end of str. The last line of code will print line the letter A, since the substring method call returns the character at index 0. Okay, now we need to figure out what this call to scramble CDE does. Just like before, these 3 lines of code execute. The first prints D, the second calls scramble E, and the third print lines C. And now we need to figure out what the call to scramble E does. This is our base condition, so all that happens is this line of code which prints E to the console. At this point, we're basically done with our analysis because we've traced the output of every call we make to the recursive method. All we have to do now is work backwards, substituting each method call with its actual output. So first we'll replace scramble E with its output, a single print statement. Then we'll replace scramble CDE with these 3 lines of output. That means the call to scramble ABCDE, the call that kicked off this whole process, produces these 5 lines of output. So now we simply need to write down the result of those 5 operations, executed in the order shown. First B is printed, then D, and then E. Then C is print lined, which means after C is added to the console, the cursor moves down to the next line. Lastly, A is print lined, just like this. And that's it. Let's check our analysis by running our code and making sure we get the correct output. Good. So that's how you can predict the output for any recursive method. The process is a bit time-consuming, but it does give you the correct answer every time. And that wraps up this lesson on analyzing recursive methods in Java. I'm Andy. Thanks for watching and coding with me today.